Hi everyone, welcome to Yourpedia Education. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering. Today in this video, we are going to solve some 50 questions from network analysis from different concepts which are suitable for BEL examination. We are not just solving the questions, we are going to learn the concepts through these questions. So without wasting our time, let's dive in. Okay, the very first question, he given some 4 branches. Yes, he given some 4 branches. He's asking, yes, what is the current I3? Calculate the value of I3. Yeah, just after looking at this question, immediately something should pop up in your mind is this is the application of KCL, Kirchhoff's current law. Yes, KCL, that is Kirchhoff's current law. What KCL says is sum of the incoming currents must be equal to, see, sum of the incoming currents is equal to sum of the outgoing currents, sum of the outgoing currents. Yes, you see, this is a node, what are the incoming currents? I1 is incoming, okay, then I4 is also incoming, that's fine, then I3 is outgoing, I2 is also outgoing, so I1 is 7 plus I4 is 3, that is I3 is I3, we have to calculate, plus I2 is 2. That implies 7 plus 3, 10, 10 minus 2 is 8. From this one, I3 is equal to 8 amperes. How much it is? I3 is equal to simply 8 amperes. Option is B. Right? Just a very simple question. Application of KCL, Kirchhoff's current law. KCL is derived from law of conservation of charge. So there is a probability for this kind of question also to ask. And KVL is derived from law of conservation of energy. KCL is derived from law of conservation of charge. KVL is derived from law of conservation of energy. Right? Let's get into the next question. Kirchhoff's law fail in case of. Kirchhoff's law always success except one place, that is distributed networks. Yes, linear networks Kirchhoff's law is applicable, both KVL, KCL, both, right? Non-linear networks are linear networks, yes, it is applicable. Dual networks, it is applicable, but for distributed parameter networks, yes, Kirchhoff's law will fail. Means here KVL comma KCL fails. KVL comma KCL fails for these distributed parameter networks, right? Let's go to the next question. Okay, what is this? In the circuit shown below, the current through 10 ohm resistance is. So this can be done in many ways. Okay, this problem can be done with the source transformation. Convert this voltage source in series with resistance as current source in parallel with resistance. This also in the same way. Then you apply current division or nodal analysis. What is nodal analysis? Okay, or with mesh analysis also you can do. This is 0 volt, it is taken as a reference. Let me take this voltage as V. Now I am writing KCL over there. Yes, what is the KCL? V minus, I assume that this current is leaving, V minus 150 divided by 20 plus V plus 150, V plus 150 divided by 20 plus V by 10 is equal to 0. This current I am saying it is leaving, this is also leaving. You may be thinking, sir, you taken all currents are leaving. Yes, you can take some are leaving, some are entering, your wish. That is just an assumption. Okay, according to your assumption you will get your answer, but all answers finally will match. Right? Now come here, let's simplify. Then what? See, he's asking for this current I. What is I? I is equal to simply V by 10. means solve this equation, get V. What is that? V by 20 plus V by 20, how much it is? V by 10. V by 10 plus V by 10 is 2V by 10 minus 150 by 20 plus 150 by 20 will be 0 is equal to 0. So from this one we got V is equal to 0. If V is equal to 0, how much is this current? I is equal to 0 by 10, that is equals to 0 amperes. That is equal to how much? 0 amperes. But 0 is not there in any one of the options. 5 amperes, 10 amperes, minus 5, none of this. Therefore, option will be none of these. Yes. Yeah. So the RMS value of the periodic waveform as shown in figure is, see, there are different waveforms like sine, triangular, rectangular, square waveform. Rectangular, square, both will come into same category when it is concerned about RMS value. Then trapezoidal waveform, the combination of triangular and square. So this kind of waveforms. So RMS, one must understand RMS very clearly. RMS. So but I say it as SMR. What is that, sir? First you square, then you mean means average, then you root. Okay, that is the actual process. Now this is a periodic waveform with a period of 0 to t. Yes, total period of 0 to t. Yes, that 0 to t is split into two parts. One is a straight line, another one is a square waveform. Yes, so I am writing integral 0 to t by 2. What is the equation of this? What is the equation of this? This is looking like similarly y is equal to mx. Y is equal to mx. Y is this one. M, how much is the slope? y2 minus y1 means a minus 0 by x2 minus x1 into, yes, t. Okay, to whole of this one you have to square it. Root mean square. What is that? Root mean square means first you have to square it. The waveform you take and square it. Now this is split again to t by 2 to t. Yes, what is the waveform value? Minus a whole square dt. Here also dt will be there. To this total we have to put the root, that is equal to RMS. Right? Suppose if I take this is a periodic waveform, I call it as current or voltage. Yes, so now I call it as VRMS. I am taking that periodic waveform as voltage. No, it is in amperes. Okay, A is let's take it, this A is the value, not amperes. This A is the value. Voltage, I am taking this given waveform. Now under root of, come on, what is this? A 2a by t whole square. Therefore 4a square by t square into t square is there, small t square. Small t square integration will be, yes, t cube by 3. T cube by 3. T cube by 3 upper limit is t by 2 whole cube by 3. T by 2 whole cube by 3 plus, yes, t by 2 whole cube, because y is equal to mx square. This will be t square, right? This will be t square. Now this will be a square into t, a square into t. Yes, upper limit is t, t minus t by 2 is t by 2. Yes, and yes, for this one entire you have to divide with t. I forgot to write there. Let me add a white page as it is clumsy over there. Let's take it here. Let's take it here. Now what is, I am assuming that entire waveform as voltage. So VRMS is equal to under root of, yes, first we squared, after that we mean means average, total divided by time period. Average means total divided by time period. Whose average? Square average we are taking, right? Now how much we have here? Here we have it as 4a square by t square. Yes, 4a square by t square. Yes, 4a square by t square. T by 2 whole cube. T by 2 whole cube by 3. T cube by 8 into 3. Right? This is t cube by 8 into 3 plus a square into t by 2 plus a square into t by 2. So this is a t square, square times gone, t times gone, this t times gone, right? That is and this is 4, 2 times it is gone. So from that one, root of a square by, yes, I am left with 6 here and I am left with 2 here. So that is equal to under root of, yes, denominator is 6, this is a square, this is 3a square, right? 3a square, right? 3a square. So from this one, how much we get is under root of 4a square, a 2a by root 6. Now 2a by root 6, a into, this is root 2 by root 3 into root 2, root 2 gone, that is root of 2 by 3a, root of 2 by 3a, root of 2 by 3a. Option B suits very well. See, go with the process. Yes, there are some shortcuts, but sometimes shortcuts will fail, not because shortcut is wrong, because you fail to apply. Why? Because number of shortcuts you may not remember. What are the shortcuts, sir? What are the shortcuts, sir? Shortcut directly may not be applicable for this question, but these direct shortcuts are applicable if the waveform is of single type. Means suppose sine wave, in what way it is? If it is a continuous waveform, its RMS value is maximum value by root 2. Sine wave with phase shift, without phase shift, or whatever it is, but it should be a continuous waveform. Okay, it may start at 0, may not start at 0, whatever it is. This is Vm, this is minus Vm, its RMS value, right? Now next, triangular waveform. This may be this kind of triangular, or another kind of triangular, or another kind of triangular, whatever may be the type of the triangular, okay, or what is another kind of triangle possible. Yes, this is also triangle. Whatever it is, the maximum value is Vm. Now its Vrms is, yes, Vm by root 3. Its Vrms is what? Vm by root 3, right? So that is, see, depending upon the shape, it is triangular by root 3. It is sine with phase shift or without phase shift, in whatever way it is, by root 3 it is. Then square waveform is there. See, let me take one more page here and let me tell you about the square waveform also. Yes, we have a square waveform like this. Yes, a square waveform. Yes, this is a plus 10, this is a minus 10. Then its Vrms is equal to 10. Its Vrms is equal to what? 10 volts, very simply. It is 10 volts, right? So this is a T, this is a V of T, right? T and V of T. Clear? Now come here. So those shortcuts are applicable if the waveform is continuous. If it is discontinuous, process you have to take up, that is square first, get the expression for the wave, then you square it, then you mean it, then you root it. Okay, RMS, SMR, square, mean, root, right? Then the resistance of a parallel circuit consisting of two resistors is 12 ohms. Okay, see, there are two parallel resistances. There are two parallel resistances. Its equivalent is 12 ohms. How much it is? R equivalent is equal to 12 ohms, right? One of the resistance wires breaks and the effective resistance becomes 18 ohms. See, the resistance of a parallel circuit consisting of two resistors is 12 ohms. One of the resistance wires breaks and the effective resistance becomes 18 ohms. Means, so this is some R1, this is some R2, then R equivalent is 12 ohms. Now he is saying one of the resistor break. Suppose R1 is there, sorry, R2 is there, R1 is breaked. Breaked means it is open circuit. Then it's R equivalent. He is saying then its R equivalent is saying 18 ohms. How much it is? 18 ohms, right? The resistance of the broken wire is, he's asking what is R1. What is R1? Now let me do here. Yes, let me do here. That is, see, if both the resistance are in parallel combination is R1 R2 by R1 plus R2 is equal to 12 ohms. Now I assumed that R1 broken, R2 is present, then simply R1 in parallel with, as R2 in parallel with R1 is broken means its resistance is infinite, broken means open circuit. Any resistance in parallel with infinite is the same resistance, infinite will not be there. R2 in parallel with infinite is R2 only. Then how much that fellow given? That is 18. Now substitute over there. 18 R1 by 18 plus R1 is equal to 12. So from this one, yes, I'm doing the calculation over here. Observe carefully. How much it is? 18 R1 is equal to 18 into 12 plus 12 R1. How much it is? 6 R1 is equal to 18 into 12. So 6 threes it is gone. Therefore R1 is equal to 36 ohms. How much? R1 is how much? 36 ohms. Good question. Okay, it is simple question. For your explanation purpose I taken this much time, otherwise it's a matter of only 2 steps. Okay, yes, there is a lot of probability in your examination, BEL examination, to ask this kind of questions, right? Next, let's go to the next question. Here in the circuit, if C1 is equal to 2 micro, okay, and C2 is equal to 3 micro, the equivalent capacitance between points A and B is, yes, how much is C1? C1 is how much? 2 micro. Let's see, capacitances in series will be parallel combination of resistances, like formula C1 C2 by C1 plus C2. How much is C1 C2? 3 into 2, 6 divided by 5. Yes, this is 6 by 5. Oh, I have one more in series, therefore again 6 by 5 into, yes, another is C2 into 3 by, yeah, C1 C2 in parallel will be, see, why all this nonsense, I forgot to take, this is also in series. Now two capacitances are in series, two equal capacitance are in series, then this C2 in series with C2 will be C2 by 2. How much is C2 by 2? Is 3 by 2, that is 1.5 micro. 1.5 in parallel with C1, so 1.5 into, yes, C1 is how much? 2 by 1.5 plus 2, that is 3.5. Yes, see, this is the 3 by 2, 3 by 2 into 2 by 7 by 2, this gone. Yes, 6 by 7. Yes, this portion is 6 by 7, that is in parallel with this one, in series, in parallel, in series. So that way you keep solving, definitely you will get the answer. Okay, just it is a time taking process, but it is easy to see. What ultimately I want to tell you here, you can do it very simply. Okay, yes, you can do it very simply. I will give you the way. Okay, see, these 3 are in series. We taken the series combination, we got it as 6 by 7 microfarad. That is in parallel with the C1. If capacitors are in parallel, that will be, see, to this one, how much is C1 value will be added. That is in series with C2 and C2. C2 and C2 will be how much? Yeah, 3 point, C2 and C2 1.5, that is in series with 1.5. to this parallel to this one you have to apply the formula of C1 C2 by C1 plus C2, that way, right? That is again in parallel, both will be added. That is again in parallel with in series with C2, C2 and C2 in series will be C2 by 2, right? See, what my point is, 2 capacitances in series, 2 capacitances in series, 2 capacitances in series, right? C1 C2 by C1 plus C2. Next, two capacitances in parallel, that is C1 plus C2. Apply these formulas, you will get the answer. Okay, everything I given, just calculation part I left to you. Right. Next, a practical current source is usually represented by, what is the ideal current source? Ideal current source is having some current in parallel with infinite resistance. Yes, this internal resistance of ideal current source is infinite and this current is some finite value, right? But if it is practical, this is no more, this is ideal, please, this is ideal current source. If it is a practical current source, yes, it is current source symbol in parallel with some finite amount of resistance. This is Rn, which is not equal to infinite, not equal to 0. It is more than 0 at less than infinite, some finite value. Yes, read the options. A resistance in series with ideal current source, no. A resistance in parallel with an ideal current source, yes. We need not go for the remaining options also. A resistance in parallel with ideal current source, option is B. Next, three resistors of 6 ohm each are connected as shown in the following figure. Okay, the equivalent resistance between x1 and x2 is, if this point is x1, this point is also x1. If this point is x2, this point is also x2. Now x2, this point is also x2. Why is there? You see, there is a short, means these 2 points are same. If this is x1, yes, because of this short, this point is also x1. So only 2 points will form here, x1 and x2. See, I am taking here, this is x1 and this is x2. Yes, between x1 and x2 I have 6 ohms. I have 6 ohms. Again, between this x1 and x2 I have one more 6 ohms. Yes, one more 6 ohms. Again, from here to here I have one more 6 ohms, right? If I take the parallel combination from here, if I take the parallel combination, all three are in parallel, if n resistances, n equal resistances are in parallel, then the resultant will be that resistance by n. Okay, so R equivalent is equal to, yes, R equivalent is equal to 6 by 3, that is equal to 2 ohms. How much it is? 6 by 3, that is equal to 2 ohms. R, sir, I will do that parallel combination R1 R2 by R1 plus R2. R, what is, if n resistances are in parallel, this is the relationship, that is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Yes, you do it, you get R equivalent, same 2 ohms only you'll get, right? Let's go to the next question, please. Equivalent resistance between X and Y is, yes, you have to stand here, you go there and stand here. Yes, imagine yourself, you are standing there. If you see from there, these two are in series. 50 plus 25 is 75 ohms is in series. This total combination is in parallel with 75 and one more 75 is there. Total 375 is in parallel. 75 in parallel with 75 in parallel with 75 will be 75 by 3, that is equal to 25. That 25 is in series with 50. The total answer is 75. The total answer is how much? 75, right? Hello, yes or not? Come on, man. Yes. Let's go to the next question. What is the power absorbed in 5 ohm resistance? This is 5 ohm resistance. Okay, he's asking about power absorbed. Power formula in a resistance is what? Either V square by R, if you know the voltage across it, or I square into R, where I is the current through it. V square by R or I square into R. Here See, all are in parallel. This 2 volts in parallel voltage will be same. Then how much is the current in this one? Or why I am bothering about current here? I am least bothered. I want the current in this one. This 2 volts will appear across this 1 ohm, this 2 ohm, this 5 ohm also. Then the current in this one is 2 by 5. 2 by 5. So power in the 5 ohms is equal to I square, that is 2 by 5 whole square into R, yes, 4 divided by 25 into 5. So 5 times it is gone, therefore it is 4 by 5 watts. How much it is? 0.8 watts. 0.8 watts. Answer is 0.8 watts it is, right? That's simple question only. But if you see the structure, there is a possibility for you to get scared. Oh, it's a very big structure, many equations I have to write. Nothing, only one equation. This voltage is 2 volts only. How's our in parallel voltage will remain same? In parallel voltage will remain same, right? Now, for a particular toroidal inductor core, don't worry if you don't know about this word toroidal, okay? Sometimes no, some new terms will scare us. Toroidal inductor core, the inductance value obtained for 50 turns is 20 microhenry. If two such inductors are wired in parallel, then the resultant inductance is, only one thing that is important for us is inductors are connected in parallel. If two inductors are connected in parallel, then any L equivalent is equal to same as that of resistances R1 R2 by R1 plus R2. This is L1 L2 by L1 plus L2. That fellow very clearly given the value of L 200 into 200, yes, by 200 plus 200 is 400, yes, 0 0 0 0. How much it is, please? Yes, 2 ones, it is 100 microhenry. How much it is? L equivalent is how much? 100 microhenry. Yes, option is D. Option is D, right? Let's go to the next question. The value of resistance R for I is equal to 2 amperes. See, generally in the questions, that fellow will give resistance, he asks us to find a current, but here current is given, he is asking for the resistance, okay? How much is this current? 2 amperes, okay? If this current is 2 amperes, how much is, already how much is this current given by him? This current is 10 amperes, yes, 10 amperes. In 10 amperes, 2 amperes is going this way, remaining 8 amperes must come this way, right? 10 to 8, right? Now what we do is, let's apply the KVL this way. Now current is entering here plus, this is minus, okay? Polarity is, what polarity we have to take? Current entering terminal is positive, leaving terminal is negative, we know that, right? Now I am writing KVL this direction, okay? For KVL writing, you can start anywhere in the loop, but you must take the polarities into consideration. I am starting at this minus, therefore minus 40. Yes sir, this is 8 amperes, this is 10, but I am entering at the minus, this way I am moving. For writing KVL, this way I am moving. How much it is? Minus 80 plus 2 amperes is the current, R ohms is the resistance, that is equal to 0. So 2R is equal to 120. Therefore R is equal to 60 ohms. How much is R? R is how much? 60 ohms. Clear? Next question please. When P is equal to power, V is equal to voltage, I is equal to current, R is equal to resistance, and G is conductance, which of the following relation is incorrect? Yes, he is not asking which of the following is correct, which of the following relationship is incorrect. Let us see. What is first relationship is what? V is equal to under root of P into R. Let's see. What is P for a resistance? V square by R. So from this one, V square is equal to P into R. So from this one, V is equal to under root of P into R. Yes, relationship 1 is correct. That's not our answer. It's asking which of the following is incorrect, right? Next one is P is equal to V square by G. P is equal to V square by R. Yes, P is equal to V square into 1 by R is G, right? Yes, this is also correct. Let's see the third one. What is power in terms of current? I square into R. So power is equal to I square. R can be written as 1 by G. So from this one, G is equal to I square by P. Yes, this is wrong. Therefore, this is our relationship. Right? Now let's take the last one also. P is equal to, yes, P is equal to I square into R. From this one, I is equal to what? Under root of P by R. Yes, this relationship is also correct. But our answer is this one. He's asking which of the following is not correct. He's asking which of the following is not correct. Option is C. Right. Let's go for the next question. For DC voltage, an inductor behaves as, see, inductor, see, XL, inductive reactance, is equal to omega L. XL is equal to omega is 2 pi FL. DC means DC is given. DC given means frequency is equal to 0. If frequency is equal to 0, XL is equal to 0 ohms. Inductor behaves as short circuit. For DC, inductor behaves as short circuit, but that too in steady state. In the transient state, in the very beginning, at t is equal to 0, t is equal to 0 is the switch closing instant. The inductor behaves as open circuit, that is transient. But here nothing is mentioned, therefore we have to see this as a steady state condition only. Right? Let's go to the next question. A 10 ohm resistance is connected in parallel with a 15 ohm resistance and the combination in series with 12 ohm. Okay, this is a 10, yes, and this is a 15, 10 ohm, 15 ohm, that is connected in series with 12 ohm. Yes, 12 ohm. Yeah, the equivalent resistance is 10 in parallel with 15, 10 into 15 divided by 25. So 12 plus 10 into 15 divided by 25. 5 3s, 5 5s, and it is 5 2s. 12 plus 2 is 14 ohms. No, option is not there. Any calculation mistake or data mistake I taken? Let me check. A 10 ohm resistance is connected, yes, in parallel with a 15 ohm, fine, and the combination in series with 12, that's perfect. The equivalent circuit resistance is 10 into 15 divided by 25. Okay, maybe in this calculation I committed a mistake. So 5 3s, yeah, 5 5s, 5 2s, it should be 14 only, na? Yeah, it is 14 only. I think there will be some mistake in the data, or with our common sense also, this is 12, and this combination will be definitely less than 10. This should be less than 10. You know, if two resistances are in parallel, then the resultant resistance will be less than that of the least resistance. Yeah, this is the least value, lowest value in this parallel combination. Less than this we have to get. Less than this we have to get. But answer should be 14 ohms. Okay, check the calculation once. Yeah, next question please. Three resistances of 15, 10 and 3 are connected in parallel. And the overall resistance is, just now I told, 15 in parallel with 10 in parallel with 3, then the resultant will be less than 3 ohms. Option is A. Means if you know the concept, directly you can tick for the question. You need not to wait for something. Your valuable time will not be wasted if you know the answer, right? So after this we have to go for the next question. See, total 50 questions we are going to solve in this particular topic, right? The question is about, yes, let's read it first of all. If all n sources in a linear network, okay, we must take linear elements like resistance, inductance and capacitance, but we should not take non-linear elements like diode and BJT. These kind of elements should not be taken. He's saying if all the n sources in a linear network are multiplied by a constant Kn. So he's saying that, brother, we have a linear network or circuit. Simple circuit I take, very simple. Let me take it as DC only, simple. So this is V1 I call, okay. Some resistance of R I am taking. Here let me take it as V2. Let me take it as V2, right? The current in this one is I. Okay, what is saying? All the sources are multiplied by a constant Kn, then the response get multiplied by, sources are V1, V2, response is I is equal to V1 minus V2 by R. Now he is saying, without multiplying the sources with the Kn, this is the response. Now if you multiply these with Kn into V1, Kn into V2, then new response is, so new response I2 is equal to, yes, Kn V1 minus Kn V2 by R. So this can be written as, if I take Kn common, V1 minus V2 by R, that implies Kn times of the previous response. Yes, the response also will get multiplied by Kn times. Okay, do not take more than two sources. It will waste your valuable time in doing the solution. Don't take complex circuit, but you must make sure that the taken circuit is a linear, it is having linear elements, right? Next question please. When three, it is not resistors, it is resistors. When three resistors, each having resistance of 18 ohm, are connected in parallel, what is the equivalent resistance? Yes, I have three resistance, each is of 18 ohms, 18 ohms, 18 ohms. Yes, 18, 18, 18. What is the equivalent resistance is the question. What is the equivalent resistance is the question. Now when n resistances are connected in parallel, then its equivalent resistance is R equivalent is R by N. I already given you the shortcut in our classes, that is 18 by 3. How much it is? 6 ohms. So your BEL questions level will be this level only. Okay, they won't ask much depth. Okay, next question please. In a parallel circuit with a voltage source and several branch resistors, yes, there is a voltage source, yes, and several branches having resistances, several. I taken for example only 3, right? How is the total current related to the current in the branch resistors? He is asking this current and these currents relationship. That is very simple, sir. I is equal to what? I1 plus I2 plus I3. I is equal to what? I1 plus I2 plus I3, right? If this voltage is V, this is also V. Why? All are in parallel. All are in parallel. Yes, right? Now read the options. It equals to the sum of the branch currents through each resistor. Yes, option A itself is correct. Yes, yeah, branch, see, this total current is equal to sum of the currents through branch resistors, right? Option A itself is correct. Next, in a series circuit, three resistances of 2 ohm, 4 ohm and 6 ohm are connected to a 12 volts DC supply in series. Yes, series. 2 ohm, 4 ohm and 6 ohm are connected to a, yes, 12 volt DC. This is 2 ohm, this is 4 ohm, this is 6 ohm. What is the question? The voltage across 4 ohm resistance is, yes, is asking this V4, voltage across 4 ohm is equal to, apply voltage division, 12 into 4 by 2 plus 4 plus 6. So V4 ohm is equal to 12 into 4 divided by 10, 12, yes, 12 gone, it is 4 volts. Option is A, 4 volts, right? Option is A, 4 volts. Next question please. 1 coulomb per second is equal to coulomb per second. Coulomb per second. A coulomb means what? Charge. Q. Second is T. dq by dt is nothing but current I. Yes, current I. So what are the units? Amperes. Current units are what? Ampere. Right? Option is D. Next question, please. In an element, let W be the energy and Q be the charge. What is the voltage across the element? What is voltage? Voltage is the one which is, voltage is the work done. Voltage is work done in bringing a positive charge, right? In bringing a positive charge, dW by dq. dW by dq. So V is nothing but W by Q. So answer is dW by dq. It is not W minus Q. It is not W into Q. It is not W plus Q. Answer is dW by dq. From the definition in the class, I already told you these units are joules per coulombs, or it is also called as volts. Called as volts. Next, what is the product of form factor and peak factor? What is form factor? I told you form factor is equal to RMS value by average value. What is peak factor? Peak factor means not power factor. Okay, people will misunderstand between peak factor and power factor. Peak factor means maximum value by RMS value. If you multiply these two, RMS will get cancelled, then you are going to get maximum value by average value. Yes, you are going to get what? Maximum value by average value. Option is D. D for Delhi. Option is D, right? Next question, please. The voltage division and the current division forms, I told you, the concept of duality. Voltage and current are duals. Star, delta are duals. Capacitor, inductor are duals. Resistance, conductance are duals, right? Mesh and node are duals. Mesh and node are duals. Voltage division and current division are also duals. That is a dual pair. It is not orthogonal pair. Orthogonality means 90 degrees angle. Complementary pair, no. Conjugate pair, no. It is a dual pair, right? Next question. Determine the power delivered by the current source in the figure. Okay, that fellow given this current as 4 amperes. If this current is 4 amperes, 4 into 2, this voltage is 8 volts. Yes, this and this both are in parallel, therefore this voltage is also 8 by 4 is 2 amperes. So this is 4 amperes, this is 2 amperes, this total is 6 amperes. This is 6 amperes, this is what? 6 amperes. I is simply 6 amperes. Is asking power delivered. Power is equal to voltage into current. Okay, current is how much? This is 6 amperes. But we want its voltage V. Write the KVL. Yes, write the KVL this way. Yeah, voltage across current source we don't know. Minus V plus what is this? 5 into 6. 5 into 6. What will be this? 8 volts. 4 into 2, 8 is equal to 0. So V is equal to 38 it is. So then power is equal to, this is in watts in fact. So 38 into current is 6. Yes, how much it is? 180 plus 48. Yes, this is 8, this is 2. 228 watts exactly. 228 watts exactly it is, right? Next question, please. Using the method of mesh currents, any resistance common to two meshes has, see, let's take 2 meshes for example. Yes, simple circuit, anyone can imagine. Being an electrical engineer, anyone can imagine this simple network. This mesh current is I1, this mesh current is I2. Then he is asking what, sir? Using the method of mesh currents, any resistance common to 2 meshes. Yes, this is the resistance common to 2 meshes has 2 opposing mesh currents. Yes, this is I1, this is I2. This is having this, the current in this one is I1 minus I2. Let's go through other options also. One common mesh current, no, it is not. See, this common element is having 2 mesh currents. Okay, 0 current, no. Half of the sum, no. Option is Pakka A. Option is Pakka A, right? Next question, please. Which of the following is false about 3 unequal resistances connected in parallel? three unequal resistances in parallel. Irrespective of resistances, if you connect in parallel, voltage will remain same. Voltage will remain same. As voltage is same but resistances are different, currents are also different. Why? Current is equal to voltage divided by resistance. As resistance are different, therefore currents are also different. Fine. Voltages are same, currents are different. Voltage across each branch is same. Yes, correct only. But he's asking about what? A false statement. Reciprocal of the, yeah, if you want equivalent resistance, no, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We know this one very well. We know this one very well. Right? Yeah. Reciprocal of the net resistance of the entire circuit is equal to the sum of the reciprocals of the individual resistances. Yes, this is also correct. The sum of the branch currents is equal to total current supplied by the battery. Yes, this is also correct. Yes, if this is I is equal to, yes, I1 plus I2 plus I3, I1 plus I2 plus I3. Current in each branch is equal. No, this is wrong. That is our answer. Because he is asking for the false statement. He is asking for what? False statement, right? Next question. The equivalent resistance between point A and D is. He is asking between points A and D. If he is asking between A and D, this is floating, this is floating, we can leave, right? Now, these two are in series, yes, and these two are in series. If these two are in series, this is 20, this is 20. 20 in parallel with 20 will be 10. 10 means this is 10, this is 10, and this is 10. 10, 10, 10. Yes, total, this is point A, this is D. RAD is simply 30 ohms. How much is RAD? 30 ohms, right? RAD is 30 ohms. Next question, please. In the below circuit, find the equivalent resistance R equivalent. In this kind of cases, if no source is given, you connect a 1 volt source. This is 1 volt. And imagine this current as a sum Ix. Now what is R equivalent? R equivalent is equal to 1 by Ix. Yeah, resistance is equal to voltage divided by current. The voltage is 1 volt, current is Ix. Right? If this is 1 volt, this is 1 ohm, this current is 1 ampere. This current is also 1 ampere, right? And this is 2I. I is equal to 1. Therefore, this is also 2. Why 2? 2 into I. I is 1. How we got I? I connected 1 volt battery for finding equivalent resistance. Whenever there is no independent source, we will connect one independent source. We take the ratio of voltage to current. Then we are going to get equivalent resistance, right? Now, Ix is equal to, according to KCL, 1 plus 2 plus 1, 3, 4 amperes it is. So, R equivalent is equal to 1 by 4 ohms. Any mistake we committed in the calculate? No, this, why this is 1 ampere? No, this is wrong I did. This voltage is 1, this current is 1 by 8. Why? Voltage is, yes, 1 volt. Yeah, this 1 volt will appear here. Resistance is 8 ohms. No, 1 by 8. Ix is not 4 please. Ix is 1 plus 2 plus 1 by 8. 3 plus 1 by 8. How much it is? 25 by 8. This is wrong. 25 by 8. Then R equivalent is equal to 1 by 25 by 8. So 8 divided by 25. I can write it as 80 divided by 25 into 1 by 10. So 25, 3s are 75. So 0.3 change will be the answer. 0.3 change. So option is A. Option is A, right? Next question, please. VI characteristics of a device are shown in the figure below. The element is, yeah, if you look at it, is pakka non-linear. Why? Only y is equal to mx is linear. In fact, y is equal to mx plus c is also non-linear. An element is said to be linear if it satisfies both superposition and homogeneity, right? Non-linear. Yes, it is yes, bilateral. Yes, it is bilateral. Yes, non-linear, bilateral. Yes, and it is active or passive? It is passive. Why? Current positive, voltage positive. If current is negative, yes, voltage is, if current is negative, voltage is also negative. Negative into negative, positive, power is positive. Positive into positive, power is positive. If power is positive, that is passive element. If it is active element, if V positive, I negative. If I positive, V negative. That way it should come. But positive positive or negative negative, therefore it is passive. What it is? Passive, right? So non-linear passive bilateral option is B. B for Bombay. B for Bombay. Next question please. A capacitor of 100 microfarads is charged to 10 volts through a resistance of 10 kilo ohms. It would be fully charged in. I explained you in class that yes, for full charging of capacitor or for full storage of inductor, approximate time taken is 5 times of time constant. Yes sir, that we call it as simply settling time, that is equal to how much? 5 tau. Tau is equal to RC for RC network, R equivalent into C equivalent. In fact, the units of tau are seconds. Therefore, settling time is equal to 5 into what is tau? Tau is how much? R into C. R is 100 micro, 100 into 10 to the power of minus 6 into 10 kilo, 10 into 10 cube. Therefore, you see 10 square, 10 to the power of 10 cube. Yes, any mistake I am committing? 10 square, 10 cube. 10 cube into 10 cube is 10 to the power of 6. 10 to the power of 6 into 10 to the power of minus 6 is 5 seconds. That's all. Option is A. Option is A, right? Next question, please. The value of R in the below circuit is, he is asking about R. That fellow given voltage here. This voltage both are same. Then how much is the current here? This is 1 ampere. How much is this current? 3 amperes. Then how much is this current? Apply KCL here. Yeah, some of the incoming currents I don't know, must be equal to some of the outgoing currents. What are the outgoing currents? 1 plus 3, that is equal to 4. Yes, so this voltage is going to be 4R. Now write the KVL. Minus 200 plus 4R plus 24 is equal to 0. Therefore 4R is equal to 200 minus 24. 200 minus 20, 180. 180 minus 4 is 176. So R is equal to 176 by 4. 4 fours and 4 fours. How much it is? 44 ohms is the option. It is C. Next question. Under root of L by C has the dimension of, yes, under root of L multiply with omega. Here also you have to multiply with omega, therefore value is not going to change. Therefore this is XL. This is 1 by omega C will be XC. This is in ohms. This is also in ohms. Under root of ohm into ohm is ohm square. Its units are ohms. Ohms means what? Resistance. Right? Yes. Next question please. The total power consumed in the circuit shown in figure is asking about the total power consumed, not see, but one thing is very clear that power consumed is equal to power supplied. Yeah, according to law of conservation of power or law of conservation of energy, how much power is given, that much power will be absorbed. Power given and power absorbed both are equal. Yes. Now this is 2 volts. This current is 1 ampere. Yes. From here 2 amperes is coming, therefore here this is 1 ampere. Now how much it is absorbing? It is absorbing 2 watts. This is absorbing. Sir, how can we say current is entering into the positive terminal? This is absorbing. Anyhow, this is resistance. Being a resistance, it will absorb I square into R. This is 2 watts. This is how much? This current is 2 amperes. Therefore this will absorb. This is 2 amperes. How much is the power absorbed? 2 square, 4 into 2, 8 watts. So, but this is absorbing. Resistance anyhow will absorb, this is resistance anyhow will absorb. This is absorbing. Here this voltage source is also absorbing, that is given by the current direction. Therefore all are absorbing. Definitely this fellow must give how much it is. Yeah, how much it is. Yes, how much is the total power absorbed? How much it is? 8 plus yes, how much it is? This is 2 plus 2. How much it is? 12 watts is the absorption. Sir, that absorption must be equal to this supply. If I know this voltage into current will be supply. How much is the voltage? Yes, this is 4 volts. Yes, this is 2, 4 plus 2, 6. Yeah, 6 into 2, 12 watts. Perfectly it is tallied, right? Let's go to the next question. In the circuit shown in the given figure, the current is asking about this current. Here the bridge is not balanced. What is bridge balance? if the multiplication of this resistance with this resistance is equal to this into this, then the bridge is said to be balanced. But in this case, bridge is not balanced. Then what we do is this way. These two are in parallel. First of all, let's find first the total current. Those are in parallel, 1 in parallel with 3, this is 4 in parallel with 2. So what are the total equivalent resistance? Total equivalent resistance is 1 in parallel with 3 by 4 plus 2 in parallel with 4, 2 into 4 by 2 plus 4, 8 by 6, 8 by 2 into 4 by 8 by 6. So 2 3s, 2 4s, 3 by 4 plus 4 by 3. So R equivalent is equal to, this is 12, 4 3s, 3 3s 9, yeah, 3 4s, 4 4s 16, this is 25 by 12 ohms. Now the current I is equal to 10 divided by 25 by 12, yeah, 120 by 25 is the current, 120 by 25. So this current is 120 by 25. So in this current, apply current division here, you get this current, then remaining current will be this, and again this current minus this current will be this current, right? According to KCL, yes, something is coming here, in that something is going, the remaining current will go here. Now let me find out this current, how much it is? 10 into yes, opposite resistance 3, not 10, it is the current is total, how much it is? 120 by 25, 120 by 25 into 1 ohm current is opposite resistance 3 divided by 3 plus 1 is 4 3s, it is 90 divided by 25. This current is 90 by 25, right? Again, sir, I want this current, that current is 25, please, it is, do not miss it as a 28. Yeah, how much is that current, sir? Yes, how much is that current? Total current 120 by 25 into opposite resistance is 4 divided by 6. See, 420 it is yes, 5, let's keep it as divided by 25 only. How much it is? 120, 20 into 4, 80 divided by 25. So what is the current that is going to this one is 90 divided by 25 is the previous current, this current, minus this current will be this current. How much it is? 10 divided by 25. Therefore how much it is? 10 divided by 25, 5 5s, 5 2s, answer is happily 2 by 5 amperes. Option is D. Option is D for Delhi, right? Let's go to the next question. The current in resistor R shown in the figure will be, yes, is asking this current. Question is looking big, but 1 or 2 equations are more than enough. As I told you number of times, questions in BEL will be 1-liner or 2-liner for the solution. See here, solution means number of steps are more, but it doesn't mean that this question is complicated. No. Come here. The current in the resistor R shown in figure will be, yes, is asking that current. Now I can convert this one into voltage source in series with resistance. Now please ignore that 1K parallel with the 1 ampere. Now this is going to become, yes, 1 ampere. 1K means this will become 1000 volts. 1000 volts, but voltage is very high. See, 1K, this should be 1 milli. Otherwise, let's take it as 1 milli. Otherwise 1000 volts it is going to become. Now this is 1 volt in series with 1 kilo ohm, remaining all are 2 volts 1 volt, therefore this also should be 1 volt. If this is 1 milliampere, 1 milliampere into 1K will be, K milli will get cancelled, you are going to left with 1 volt. Okay, now these two elements are not there. Okay, now let me take this one as voltage V. I'm writing KCL. What is that? V minus 1 by 1K, I'm not writing that K, plus V minus 1 by 1K plus V minus 2 by 2K. 2K is equal to 0. So V plus V, 2V plus V by 2. How much it is? 2 plus 1 by 2, 3.5 minus 1, 1, 2, 4. 3.5 is equal to 4. V is equal to 4 by 3.5. V is equal to what? 4 by 3.5. Now that current this current, let's take it as some I. Now he's asking that current only. I is equal to, we have voltage, how much? 4 by 3.5 minus 1 divided by 1k. How much it is? 4 minus 3.5, 0.5 by 3.5. So 1 by 2 by 7 by 2. So 1 by 7 will be the answer. So approximately in that range you will get. Okay. Check it. I hope there is some calculation, not calculation mistake. The question framing mistake is there. That's why our answer is not matching with the options. This should not be 1 ampere. If it is 1 ampere, according to source transformation theorem, voltage will be 1000 volts. That will be a very big number. Okay. So check it once, please. Yeah. Now this question is, current having waveform shown in figure is flowing through in a resistance of 10 ohms. The average power is. Power, whatever may be the shape of the waveform, average power depends upon IRMS square into the resistance value. What is the RMS value of this one? I given you triangular waveform, whatever may be the shape. If it is a continuous waveform without any discontinuities, whatever may be the shape, RMS value will be maximum value by root 3. How much it is? Maximum value is 10 by root 3 whole square into resistance is how much? 10 ohms. It is 100 into 10, 1000 divided by 3 watts. 1000 divided by 3 watts. So option is C. C for Chennai. Option is C. Right? Next question, please. The current I4 in the circuit of the figure is equal to, is asking this current. Now this is just the application of KCL. Application of KCL it is. Let us see. Yeah. So this current we know, how much it is? 5. How much it is? 7. Now how much should be this current? 5 plus 7, it is 12 amperes. If that is 12, this way it should be 12, but that fellow is asking this way. Therefore on the same branch, if you are taking two different directions, one current is opposite to other, therefore answer is minus 12 amperes. People immediately they will go and take option A, but that is wrong. Option is B for Bombay, minus 12 it is. Right? The voltage V in the figure is always equal to, is asking this voltage V. Now tell me, see, I write the KVL, outside KVL this way. I'll start from here. Anywhere, I told you number of times that if you want to write KVL, you can start at any point and you can end at the same point. You have to end at the same point, but during that journey you must follow KVL sign convention. Okay, KVL sign convention. So minus 4 plus 5 plus V minus 4 is equals to 0. So V is equal to 8 minus 5 will be 3 volts. Answer is 3 volts. Option is happily A. Right? Option is. Let's go to the next question. The voltage V in figure is always equal to. From here, one very good point we can learn, that is voltage across current source is unknown. We have to find if sufficient data is mentioned. Now this voltage I don't know. Voltage across any current source is unknown. We have to find. Now current here in this one is 2 amperes, therefore this will be 4 volts. This is 5. If I write the KVL, minus V plus Vx plus 4 plus 5 is equal to 0. So he's asking about V. V is equal to what? Vx plus 9. Yes. If I know this Vx, I can get this V, but voltage across current source is unknown. We need to find. But if we want to find, there should be some data related to it which is not there in this particular problem. Therefore, yes, none of this. We can't find. We can't find, right? Next question. The energy expanded in a resistor R in joules when the current of I flows through it for t seconds is. See, energy in a resistor will dissipate in the form of heat. That heat is equal to I square R into T. If it is DC, you take DC current, but if it is AC, in place of this you have to take IRMS. RMS value of the current you have to take. I square RT. Option is A. I square RT. Option is A. Right? Yeah. An ideal voltage source will charge an ideal capacitor. Yes. Ideal voltage source is going to charge ideal capacitor within 0 time. Why? Tau is equal to R into C, brother, right? Ideal capacitor resistance is 0. The time constant is 0. Then the approximate time to charge is how much? 5 tau I told to you, that is equal to 0 seconds. Immediately it will charge, that is instantaneously. If it is a practical capacitor, it charges exponentially, right? Let's go to the next question. For the circuit shown in figure, the value of the R for critical damping. Critical damping means zeta is equal to 1. It is parallel RLC circuit. What is the zeta value of parallel RLC? Zeta is equal to 1 by 2R into root of C by L. For series RLC, zeta is equal to R by 2 into root of C by L. Sorry, this will be L by C. This is L by C. Any one of those two, remember that, and this both are duals with each other. This is for series RLC. This is for series RLC. This is for parallel RLC. Zeta is equal to 1 by 2 into R. How much is the resistance, ma? How much is the resistance? Okay, he's asking for us to find the resistance. Zeta value is given. Zeta is equal to 1 into under root of L, 7 Henry, divided by C is 1 by 42, that will become 42, right? So now R is equal to, yes, under root of 7 into 42 by 2, right? If you solve, you'll get the answer. Under root of 7 into 42 by 2. Yes, how much is under root of 7 into 42? Yes, let me do here. Yes, under root of 7 into 42. 42 can be written as 7 into 6 divided by 2. So, root 7, 7. 7 into root 6 means nothing but root 3 into root 2 by 2. So this root 2 times this will get cancelled. Okay, 7 into root 3 by root 2. If you solve, you will get. That's not a big question, right? Next question. The time constant associated with the capacitor changing in the circuit. It is not changing. It is, in fact, it should be charging. Capacitor will get charged. Why? Capacitor will change. It's not variable capacitor. Tau is equal to R equivalent into C equivalent. What is R equivalent? You stand here, brother. Voltage source is short circuited. 2 in parallel with 3. 2 into 3 by 2 plus 3. Yes, it is 6 by 5. And C equivalent is how much? 6 by 5 into C is 5 micro. Yes, the answer is 5 gone. It is 6 microseconds. Answer is what? 6 microseconds. Choice A perfectly suits for the given question, right? Next question, please. The time constant of the network shown in the given figure is given by time constant. Yes, you stand here. Yes, R1 in parallel with R2 plus R3. Yes, this is R equivalent. Tau is equal to L by R. So L is L by R is, what is R1 in parallel with R2? R1 R2 by R1 plus R2 plus R3, right? Option is A, L by R1 R2 by R1 plus R2 plus R3, right? Choice is A. Next question. The circuit shown in the figure is excited by V into del of T impulse. The peak voltage at the capacitor is asking what is the highest value of voltage across capacitor. For that, first of all, we must have the expression for voltage across capacitor. What is VC of S? VC of S is equal to VA of S is V. Why? Because del of T Laplace transform is 1, right? 1 by CS by R plus 1 by CS. So VC is equal to V into 1 by SER plus 1. So VC is equal to V by RC into e power minus T by RC. As it is exponentially decreasing or decaying, at T is equal to 0, its value will be V by RC. That itself is the highest possible value. Answer is V by RC. V by RC. Next question, please. in the circuit shown, Vc is 0 volts at a t is equal to 0 seconds. Okay, for t greater than 0, the capacitor current IC of t, where t is in seconds, is given by, he is asking current through capacitor. What is the initial voltage of the capacitor? 0. What is the final voltage? Yes, final voltage will be voltage. See, finally capacitor behaves as open circuit, therefore this voltage will be the voltage division, that will be 5. How much is R equivalent? R equivalent is equal to 10k, right? C equivalent is equal to 4 microfarads, right? Now Vc of t is equal to V final plus V initial minus V final into e power minus t by tau, right? So we got Vc, but he is asking what? Current through capacitor. Current through capacitor, IC is equal to C into dVc by dt. That is best for us, no? Yes. So this will be 0 minus of minus plus derivative means plus 5 by tau, plus 5 by tau, yes, into e power minus t by tau. How much is 5 by tau? Tau is how much? Tau is equal to R equivalent to C equivalent 40 into 10 to the power of minus 3, 40 into 10 to the power of minus 3. Therefore tau is equal to 4 into 10 to the power of minus 2. So 5 divided by, yeah, any calculation mistake we committed? I don't think. Just check the calculation mistake if anything we committed. Yes. The answer, what is tau first of all? Tau is equal to t by tau. Okay. So this expression, with this expression we go with the elimination process, e power minus t by tau is 0.04. This will be, I think, 25. 1 by 25. Yes, e power minus 25 t, e power minus 25 t. Either option A or B. You check this one, e power minus t by tau. Okay, tau is very small. Okay, the current should be in kiloamperes. Voltage is volts only. Yes, this is Vc of t is equal to V final plus V initial is 0 minus V final is 5 into e power minus t by tau. That's fine. I is equal to C. Yeah, I forgot to multiply this one with C. I is equal to C dV by dt. Na? Just I wrote dV by dt. I forgot to write into C. What is C? C is 4 micro. C is 4 microfarad. So 5 into 4. See how much I got? 5 divided by tau. How much is 5 divided by tau? Tau is 0.04. Yeah, 5 divided by 0.04 into 4 micro, 4 gone. Answer is this 0.50. Just calculation you have to check. Okay, next question please. An inductance and a capacitance are connected in series. Okay, inductor, yes, and capacitor both are connected in series. Okay, if a unit step voltage is applied across this combination, okay, across this combination, if unit step across this combination, if unit step voltage plus minus u of t volts is applied across this combination, then the initial and final currents in the circuit will be, initially capacitor acts as a short circuit and inductor acts as open circuit. Initially this is open circuit, therefore current is equal to 0. Finally this is short circuit, this is open circuit, even finally also current is 0. Initial current is 0, final current is also 0, because initially capacitor acts as initially inductor acts as open circuit, no current. Finally capacitor acts as open circuit, no current. Right? Next question. A linear element satisfies the property of superposition and homogeneity. Superposition and homogeneity. Option is A. See, this way, see, almost we covered most of the concepts of network analysis from DC and transients, some part of AC also, right? These are the 50 good questions through which you can learn concepts. You can apply the concepts for learning network analysis. Yourpedia is one of the largest platform for training modules like BEL, BHEL and these kind of written examinations and interviews, right? You can join your hands with Yourpedia to accelerate your preparation towards your BEL written examination preparation. Thank you.